In the 18th century, Swedish botanist Carolus Linnaeus designed the flower clock, a timepiece made of flowering plants that bloom and close at specific times of day. Linnaeus' plan wasn't perfect, but the idea behind it was correct. Flowers can indeed sense time, after a fashion. Morning glories unfurl their petals like clockwork in the early morning. A closing white waterlily signals that it's late afternoon. And moonflowers, as the name suggests, only bloom under the night sky. But what gives plants this innate sense of time? It's not just plants, in fact. Many organisms on Earth have a seemingly inherent awareness of where they are in the day's cycle. That's because of circadian rhythms, the internal timekeepers that tick away inside many living things. These biological clocks allow organisms to keep track of time and pick up on environmental cues that help them adapt. That's important because the planet's rotations and revolutions put us in a state of constant flux, although it plays out in a repetitive, predictable way. Circadian rhythms incorporate various cues to regulate when an organism should wake and sleep and perform certain activities. For plants, light and temperature are the cues which trigger reactions that play out at a molecular scale. The cells in stems, leaves, and flowers contain phytochromes, tiny molecules that detect light. When that happens, phytochromes initiate a chain of chemical reactions, passing the message down into the cellular nuclei. There, transcription factors trigger the manufacture of proteins required to carry out light-dependent processes, like photosynthesis. These phytochromes not only sense the amount of light the plant receives, but can also detect tiny differences in the distribution of wavelengths the plant takes in. With this fine-tuned sensing, phytochromes allow the plant to discern both time, the difference between the middle of the day and the evening, and place, whether it is in direct sunlight or shade, enabling the plant to match its chemical reactions to its environment. This makes for early risers. A few hours before sunrise, a typical plant is already active, creating mRNA templates for its photosynthesizing machinery. As the phytochromes detect increasing sunlight, the plant readies its light-capturing molecules so it can photosynthesize and grow throughout the morning. After harvesting their morning light, plants use the rest of the day to build long chains of energy in the form of glucose polymers, like starch. The sun sets and the day's work is done, though a plant is anything but inactive at night. In the absence of sunlight, they metabolize and grow, breaking down the starch from the previous day's energy harvest. Many plants have seasonal rhythms as well. As spring melts the winter frost, phytochromes sense the longer days and increasing light, and a currently unknown mechanism detects the temperature change. These systems pass the news throughout the plant and make it produce blooming flowers in preparation for the pollinators brought out by warmer weather. Circadian rhythms act as a link between a plant and its environment. These oscillations come from the plants themselves. Each one has a default rhythm. Even so, these clocks can adapt their oscillations to environmental changes and cues. On a planet that's in constant flux, it's the circadian rhythms that enable a plant to stay true to its schedule and to keep its own time.